is it, guys. This is one of our last days of class. Of course, we still have another week or so, but this is an important day, as you guys are going to see here. Let's get more participation. I see some purple lines. I like purple, but there's like a lot of other colors as well. Let's get some more colors. Let's get some green, some blue, and some yellow. All right, Giselle, good choice of colors there, Giselle. I like your color scheme there. Nice. Let's get some. Okay, he's got some black and some green. Sorry, guys, cough into the mic here. Okay, black and green. Nice. Okay, good, good. All right, what else do we have, guys? What else do we have? Okay. I see some more lines there. Good, good. All right. Yeah, good morning, Frank. Good morning. Welcome to Monday. Well, the good thing, guys, this week is going to be a short week, right? It's going to be a short week because Thursday's a holiday. Okay, well, let us go forward here and just see where we are at. So you guys said that a closed circuit is one in which current can flow. And I see that makes sense, right? You're closing the gap, right? So people can walk across it. Okay, so that makes sense. An open circuit is just like it's open and you can't go across the chasm, right? So current is broken, it's off. A switch, you guys know what a switch is, right? Of course, you've got light switches in your house. Hopefully you have light switches in your house. Well, now I have, what do I have? Alexa. I just talked to Alexa and Alexa turns my lights on for me. So that's pretty cool too. A series circuit has one path, right? Like a long line, like a bunch of people in a row. And a parallel has more than one possible pathway for electricity. Okay, you guys know this slide, the do not share personal information. Make sure you guys participate, and then participate. And of course, this class is being recorded to be distributed to students who may not be here today. All right, there it is, guys. So this makes me happy that you guys are almost going to get credit for the class. Not happy that we're not going to see you guys anymore, but happy that you guys are going to get, if you're passing and everything, you're going to get your 5 credits for graduation, which is great. You guys are getting close to 5 more credits here. Make sure you guys are passing. Today is the 8th of November, of course. Look at this, Thursday is going to be a holiday, so there's good news there for you guys as well. All right, so make sure you guys get those notes 5F open. So guys, look in over that side there. Go ahead and look at the chat box for your notes. Go ahead and click on them and raise your hand so we know that you guys have them open. Marion, you were fast today. You're the first one. Marion, Wilpine, and Giselle. Good job. All right, Will. Good job too. So get those notes open, guys. Hands up, so we'll know that you guys have them. Okay, so today we're going to talk about circuits part 2. So, we talked about electromagnetism, charges, all these things, magnetism and motors. Today is going to be the last part of circuits. That's it, right? That's it. So we're going to be almost done here. All right. Our final exam is going to be coming up in place of the project. So I know we talked about this before. We announced it before. Hope that's good news for you guys. If you guys haven't finished your project, this is your time to do it. You can totally get it done still. You've got projects that are outstanding. Okay, and Ms. Sapolga has some important announcements here for you guys as well.
Alrighty, good morning everybody. I'm going to get a last few people on my attendance. Again, if you get that pesky little call, just kind of ignore it. I know you're here. Hopefully I got it in time. All right, so let's go ahead and talk a little bit about our announcements here. As of this afternoon, I'm going to go ahead and zero out all our work. That means I'm going to zero out our final exam, even though we have not taken it yet. I'm zeroing everything out. The reason for that is because it will inform you on what you need to do in these next couple of days. At this point, once I zero everything out, even our final exam, the only thing that's going to happen to your grade is that it will go up. Anything that you turn in is going to raise your grade up. Okay, so your grade cannot go any lower after I zero everything out. It shows you exactly what you need to do on your final exam, where you need to go, what path you need to do. If you have a pretty decent grade going into the final exam, then you can go, whew. Yeah, I have to do well, but it's not, the pressure is not on. If you're not doing so well, it's probably because you need to get some projects in and you're complete your final exam, but at least you know where you're headed so that you have every opportunity to get everything in. Once I zero out all your grades, remember that doesn't mean you can't turn anything in. You technically have until November 17th at 11:59 to turn in everything on in this class. So that means unit 1, unit 2, unit 3, unit 4 projects, your final exam, you have and some of your notes. Okay, so please be aware of that, and that just because I zero everything out does not mean that you cannot turn in anything. Okay, so just be aware. Like I told you before, the next couple of days we're going to go over the final exam together. We're going to make sure we're going to make I'm sure you are in, so make sure you're in class. The final exam is a test. Miriam, I really wouldn't call it a final exam. It's only on Unit 5, only on the stuff that we just did. It's simply because you've already shown your mastery for Units 1 through 4 with your projects. So really it's only going to focus on Unit 5. There may be a couple of questions on on the Unit 4 part, but it's really we're going to go through every question in class. It's not going to be like notes, but we'll review each question and then I will give you time to work on that question. Okay, so again, it's not going to be like notes where I'm going to give you the exact answer, but I'm definitely going to kind of help you out on how to find it. Okay, and if we don't get through it all in class, you will have a recording, so that you can go have every question for the final exam. When is it, Giselle? It starts tomorrow. It's going to be actually 2 days. Okay, so it's going to be like a 2 day note kind of a thing. Okay, so hopefully we can get through it to half of it tomorrow and then half of it the next day, and then you're going to be on your own until November 17th. Okay, but you will have a recording to go along with it. All right, hopefully that makes sense for people. Anybody have any questions about Yes, Max, I should have graded it already, but I will check again because there was a couple of people that I did that I noticed that are not getting graded for some reason. So I will check on that, Max, and I will definitely take care of it. Okay? Yeah, no worries, Max. No worries, because there was a another student that said that they turned it in, and I saw it turned in, but it didn't show up on the stuff that I needed to grade, and it didn't, and does need to be graded. So I will check on you too. So no worries. Okay. With that being said, I think we're good. I don't see any. When is it? When is what, Giselle? The final exam, or I think the final exam starts tomorrow and then on Wednesday. So you have 2 days. We're gonna go over it 2 days in 2 days. So half one day, half the other day. Okay. All right. Let's go ahead and continue on here and do our last set of notes. I cannot believe it.
Super close to being done, guys. Super close to being done. So this is it. Those of you have your notes open, if you all have your notes open, they're all open here. So has everybody told us that they're open? Frank has, Miriam has, Will has. Okay, good. I'm looking here at the chat box, making sure I don't call anybody twice here. Lynn, welcome to the class. You have them open. Let's see, Raja, Nick, you might open already here. So I'm making sure we do this super well today because we're almost done here. Okay, go ahead and check that box there, and we are going to get started. So basically, we're learning about two things here today. So one is the difference between series and parallel circuits. Very important if you guys ever, again, become electricians or get into construction or something else. And then secondly, figuring out the total amount of resistance in a series circuit. And that's important if you're, setting up a circuit. You want to make sure you have enough power there in order to power all of the things that are connected to your circuit, right? I don't know if you're like me, but I have like extension cords with things plugged into it, and then other extension cords plugged into that, and I have like my computer and a light and a bunch of other stuff. You can't do that infinitely because you can run out of power. So being able to calculate the total resistance is very important. All right, so you guys talk to me. You guys tell me this here. Help me out here. I am going to look at the one on the left here first, one over here. So over there where the little orange squiggly line is. Go ahead and figure out if there is current leaving this battery, right? Current's leaving this battery. How many possible pathways does it have before it can get back? How many possible pathways? So over here on this side here, how many possible pathways do you guys see? It's almost like a little puzzle, right? It's sort of like okay, I'm sure lots of people have time to answer that. How many possible pathways do you guys see? All right, so let's see. Gabriel, Miriam, Jasmine, Christina, Lynn, and Opie. Okay, good. 3. I see 3 as well, right? I see 3 as well. Yeah, well, so I see one pathway here, right? Got that. I see a second pathway here. There you go. And I see a third pathway here. Third pathway there. So I believe you all got that as well. So is this going to be a series or parallel? Let me clear up this a little bit here. It's going to be series or parallel. Okay, you got some different opinions there. Okay. Okay. Yeah, it is going to be a parallel, right? Because there's parallel. You can think about it this way. There's like parallel universes, right? There's like parallel ways, parallel options that electricity can travel through. So yeah, it will be parallel, right? Exactly. So this will be. We'll say that there are 3 pathways, and this is a parallel circuit. There we go. All right. How about this one over here on the right-hand side? This one over here. The big green dot is there. How many possible pathways do you guys see? As the current comes out here, current comes out, goes around and around and around. There it goes. All right, Brandon, Jasmine, Miriam, Gabriel. Okay, good, good. I see Lynn, thank you. I see 1 as well. That's what I see as well. I think that's pretty, this one's pretty clear, right? You see really 1 pathway, you can't make a second one. And that is going to be called what? Gabriel, Tim, Miriam, hear from the rest of you guys. Tavon, let's hear from the rest of you guys. Jolie, JJ, Haley. Okay, it's going to be a series circuit. Right, exactly. Excellent, excellent, excellent. Okay, good, good, good. All right, so we will go ahead and hit that there. So that's the answer to questions 2 and 3. Let me make sure I answered those questions. Okay, and type here. Okay, gonna raise your hand once those are done. And I'll give you guys 20 more seconds to finish that. Let's see, looks like a couple of you guys in the chat box and raise your hand. So Frank, Julie, Wyatt, nice, Haley. All right, Miriam, Kiara. Okay, and a bunch of raised hands. Good, good. Okay, let's see everybody. Let's see who's missing. Let's see, Roman, did you get this? Welcome to the class. Good morning, Roman. Okay, Shivani's done. Roberto, Kenshana. Okay. All right, guys, good. Okay, so here's another question for you guys. This is basically learning the I guess the vocabulary, the way of saying this. We talked about a closed versus open, right? Closed versus open. And don't be confused, because if you're thinking like, the store is closed, I can't go in. That's not it. That's not how it works, right? So it's a different meaning here, a different way of using the word, a way of thinking about it here. So here we go. So what do you guys see is the difference between a closed and open circuit? This one's closed, and this one is open. What do you guys see different about that? What do you guys see different about the light, for example? Okay, Mary says 1 lights up. Okay, which one lights up? Which one lights up? Okay, the closed circuit. Okay, okay. All right. Yeah, the closed stays on. All right, good. Yeah, because it is the space is closed. Does that make sense? You're able to get, yeah, the open is off. So whatever memory aid you guys need. Again, I always think like, we got to close, make sure we close I picture the drawbridge, right? So we close it so it's sealed, right? And you can go across it. That's how I picture it, right? The circuit is closed. There's not an opening. When there's an opening, like the door is open, right? The gap is open. The hole is open, like the manhole cover, those covers on the street, it's open. If you walk over, you're going to fall in. You're not going to be able to get to the other side. So closed means it's closed and sealed. You can go over it, right? So the electricity can travel over it. And open means, there's something missing there, right? Got an open hole, an open chasm, an open whatever. So that's the difference between those two there. So remember, close is complete and open is broken. So what do you think about it? So there's don't confuse those two. It's just kind of a vocabulary thing here. All right, so let's help me out here, guys. This is Christmas time here, right? The Christmas time. And here you go. Here's the lights. You're putting them up. You're super happy. Super happy. You're like, yay, lights are up, lights are up. And unfortunately, you step backwards and crunch. There's the sound of broken glass. You're like, oh no. Um, and what happens? The lights, do they stay on or do they go out? So first of all, is there one or multiple pathways? So tell me, guys, one or multiple pathways? Let's do this one first. How many pathways do you guys see? How many pathways do you guys see? It's got lots of answers there. Okay, I see one. Whoops, there we go. Let me do that. I see one pathway as well, right? I see one pathway as well. So I see basically you're going to come here. Electricity is going to flow around there, lighting up the lights. Got the smell of your crisp pine tree. All right, there you go. You got one pathway. If we step on it accidentally, uh-oh, crunch. Ah, my foot hurts. Okay, what will happen to the lights? What happens to the light bulbs? What happens to the other light bulbs? What are they going to do? They will go out, right, Roman? Yeah, they'll go out because you've broken they stay off, right? They'll stay off. Exactly, exactly. Because you've broken the path. You've broken it. The electricity can't flow through there anymore. Exactly. It'll turn off. Right. Good. Okay. So this is the answer to question number 4. Just clears your hands there. Cleared your hands. So there is one pathway, and they are going to turn off because pathway is sadly it got broken. I think Shivani gave the question answer box. Good answer there. All right, so go ahead and raise your hands, guys. Give you guys 25 seconds on this one. Go for it. Tim, Wyatt, Tim, okay, good, got it. Let's see, anybody else we need to hear from? Let's see, Tavon, this is the chance to get it, guys, first time through. Victoria, Tim. Oh, Tim already has it. Good job, Tim. Josiah, JJ, Jade, Isaac, and Gabriel. Let's make sure you guys all get it. Okay, Gabriel has it. Good, Gabriel. Nice job there. Okay, let's see, Miss Boulder, do you want to do this one? Or you're going to get this one?
Yeah, I'm good. Okay, so we're going to do like a little live demonstration. I have this circuit set here that I got, and so I want to show you what it would be. I am working on my science projects there, Gabriel. So here we go. We're going to do a little demonstration, and I'm going to go ahead and do widescreen so that you all see me. And close this out. Perfect. Hopefully it's not as good. It's not as foggy as it was on the other day. So I have my circuit set. I have my power source right here. I have another, this would be a kind of a light bulb. And then obviously I have another one right here that already has a light bulb in. So what I'm going to do is I'm going to connect my connectors here to make a series circuit first. And so when I connect my connectors to make my series circuit, you will notice that right now it's not going to work. Why is it not going to work? Who could tell me in the chat box? Why isn't this going to work? What am I missing in my series? What am I missing in my series? I have one that has a light bulb, one doesn't. Look over here. What am I missing in my series? So just like Mr. Corniola said, yeah, exactly, Miriam, I'm missing my other light bulb. Just like Mr. Corniola said that, again, if I have a missing light bulb or if a light bulb is broken, my series circuit is not going to work. But as soon as I add my light bulb in, what's going to happen, you think? What's going to happen? Yeah, good. Open, broken. Yep, Gabriel, it is a broken circuit. It's an open circuit. Good. Now, what happens if I close it and I add my light bulb? Who can tell me? Who do you think? What do you think is going to happen? It's right there, but I haven't pushed it down a little bit. What do you obviously? Yeah, it's now going to work. So let's go ahead and try that. So I'm going to go ahead and look what I have going on here. Now I have a circuit that has now a closed circuit here. Obviously it's a series circuit, so now I have both my light bulbs working. It's alive. Yeah, exactly. So now if I go ahead and I'm just going to go ahead and take one light bulb out, okay, and I'm going to go ahead and make a parallel circuit. And in order to do a parallel circuit, I'm going to go ahead and kind of meander and do a couple of things. I have to switch a few things. Switch a few wires here. Okay, so there we go. Let me grab another one of these. So I'm going to go ahead and make a parallel. And so my parallel is going to connect with, let me go ahead and do this real fast. Okay, and I'm going to connect my red right here with my black. Oh, I just completed that circuit, so I'm going to actually take this light bulb out for a second so we can see it. And I'm going to connect these two together. Again, you're going to be watching my parallel circuit here. And if I could see, I need my glasses on for this. All right, connect this one to this one. All right, and then I'm going to connect these two together. Boop. Now, and I'll show you from like a bird's eye view, my parallel circuit. Now, when I talk about a parallel circuit, how many pathways are you going to see with a parallel circuit? And I'll show you in just a moment. But how many pathways do you think you'll see with a parallel circuit? More than one. Yeah, that's right, Miriam. Absolutely. I'm going to see more than one pathway. And look, oh man, come on, get in there. Now, I could add a switch to my circuits here. And adding a switch is pretty easy, but I don't want to add a switch right now. So there we go. So looking at this, I'm going to actually give you the bird's eye view here. So obviously, when you look at my circuit, here is my power source again. If you look here, I have one pathway that's going towards this way. And then I have a second pathway that's going around, okay? So now let's go ahead and do some experimenting here. If I take my light bulbs, I have my energy source. Hopefully this works. Hopefully I wired it correctly. Oh, I did. Look, there's one light bulb. I'll back it up so it's not like so bright in the camera. And here's my second light bulb. Okay. Now, just like we noticed though, parallel circuits, if I take one of these light bulbs out, one of them breaks. And I'm going to say this first one here is going to break. What's going to happen to the second one? Look at that. It still works, right? It still stays on because the electricity, the electrons are taking a different path. They're not taking the first path. Vice versa, if I put my first light bulb back in, so there we go. If I put my first light bulb back in, but I take my second light bulb back, guess what? My first one still works because it's taking a different path. It's taking a different path. All right, so this is just, again, a little experiment, a little showing you a little live version of exactly what I did here. So again, let's take a look in our, and for number 5, we talked about how this particular science experiment has multiple pathways, and that if another light bulb, if the light bulb stays on because there is another pathway if one breaks. All right, this is a multiple select, so go ahead and lock your answers in. I'm going to give you 25 seconds to do that. Go, go, go. And in the meantime, I'm going to go ahead and take my camera and shut it off so you guys don't get sick as I move it. Perfect. Excellent. All right. All right, make sure you raise your hand. Excellent job. Here we go. Awesome. Thank you so much, Frank. Thank you, Tim. I see you. Giselle, awesome. All right, let's go ahead and just kind of go through. Will, let me know how you're doing. Excellent. Brandon, I see you on there. Absolutely. So let's say, I'm going to go from the top. Will, Tim, I saw you in the chat box. Tavon, let me know. Roberto, Raja, Paul. Opie, let me know how you're doing, Opie. Thank you, Jolie. I see you there. Thanks, Will. I see you up in the chat box. Excellent. Muy great. Max, Nina, Nico, Natalie, Kinshana, let me know. Kira, Kamari, Kai, Jolie, I saw you in the chat box. JJ, let me know how you're doing. Excellent, excellent. Andre, Angel, Ash, beautiful, everybody. Thanks, Kinshana. Thanks, JJ. Beautiful job, everybody. Let's go ahead and move on. Nice. So now we're going to take a look at a kind of a little bit of both, a series and a parallel circuit. Looking at this particular, and I'm going to turn off my little light because it's bright in my eyes. Looking at this particular series and parallel circuit, it's actually a little bit of both. How many pathways do you see here? How many pathways do you see? Nice, Christina. How many pathways do you see here? Many. Yeah, I'll agree with you. Good, Gabriel. I agree with you on that one. It's good, Brandon. Excellent. Excellent. Good, Shivani. I see you in there. Excellent. Yeah, everybody, I agree with you. There is 4 different pathways. I have pathway number 1 right here, and I have pathway number 2 right here, and finally pathway number 3, and then at the very top there, pathway number 4. Okay, so 4 different pathways. I agree with you on that way. Now, what happens if one of these light bulbs, and I'm going to say this nice pink one here, this one of those pink light bulbs burns out? What's going to happen to the other light bulbs? What do you think is going to happen to the other light bulbs? Depending, okay. Stays on. Good, Gabriel. The rows go off, but the other rows stay. Good, Miriam. Now we're talking. I think, yes, excellent. And you're absolutely right. So what's going to happen, because this is both a series and parallel circuit, unfortunately, this whole row goes out. Okay, this whole top row number 4 goes out. But guess what? You still have row 3, 2, and 1 that are still lit. So you still have nice, pretty holiday lights. But the problem is now we have to now sit and figure out this section of the lights and figure out which light bulb is out. It's better than sitting and trying to figure out the whole string. Now we just have to figure out the section. So the holiday light company people have really kind of got us here, because instead of getting the whole string, now we have we've narrowed it down to a section. So it might take an hour instead of 4 hours. All right, to figure out which light bulb is burnt out. So, thank you, holiday light people, for considering our time here and making it kind of a sectional thing. But let's go ahead and give you the answer here. Obviously, like you told me on the other slide, you have 4 different pathways. We know that the light bulb in the same row all will turn off because their pathway is broken, but all the other rows are actually going to stay on because they are a different pathway. This is the answer to number 6. I'm going to go ahead and give you 25 seconds. This is a 3-part question. Make sure you answer all 3 parts. The pathway, what the same row is going to do, and what the other rows are going to do. All right, 25 seconds up on the clock. Go, go, go. Here we go. Raise your hand when you are finished. All righty, let me just check in with a few people here. Thank you, Haley and Frank. I see you. Wyatt, I see you. Gabriel, awesome. Thank you so much. So let's go take a look. And Andre, Angel, Ash, Brandon, let me know how you're doing. Let me see if you're up there, Brandon. Brian, Colin, Daniel, Donatella, let me know how you're doing. Emily, Esteban, Ethan, Frank, I saw you. I believe I saw you in the chat box. Yes, I did. Thank you, Daniel. Thank you, JJ. Thank you, Brandon. Excellent. Isaac, let me know how you're doing. Jacob, Jade, Jasmine, JJ, thank you so much for being in the chat box. Jolie, let me know how you're doing. Kai, Kira, Kanshana, Max, Natalie, Nick H, Nico, Paul, Raja, Roberto, Tavon, Tim, and Will. Thank you so much. All right, let's go ahead. How many pathways? It's right here there, Tim. It's 4 different pathways. Thank you, Jolie. 4 different pathways. All right, here we go.
Okay, guys. So there's this issue here, right? Of like, they step on the lights, holiday lights, and then they go out, and then we're sad because now we're going to be basically have some dead cold lights strung up with no beautiful colors, and everyone's sitting around, oh, I wish we could do something about this. Well, somebody came up with this great idea. They're like, aha, I have a solution. Okay, if I don't want to do them in parallel, I can figure out a new way to solve this. So go ahead and look down here. You guys looking down here? Look down here. Look really close. Get closer to the screen, even closer, right? Because it's kind of small here. You get closer, you can look, right? How many pathways do you guys see here? How many pathways do you guys see? If you guys looking real close there, don't miss it. How many pathways do you guys see? Look careful. All right, Kamari, yes, yes. Kamari will. Okay, yeah. So some of you are thinking one, some of you guys are thinking two. Well, there's this thing called a shunt wire. A shunt wire. See this wire that goes across here? It gives an alternative pathway for electricity. So when the bulb burns out, right, that normally would kill the rest of the string of lights. There's this shunt wire that allows the current to keep flowing, right? So even though the bulb burned out, basically the current will keep flowing back here, almost at the base. So if you stepped on this crunch, it broke off, there's still this little piece of metal here that allows the current to keep on flowing through. And they'll save the day for everybody, and everybody will be happy because there'll be lots and lots of colorful lights. So um, does the circuit break? Does the circuit break? What do you guys think? Yes or no? Yes or no? Does this circuit here? Okay, so no, yeah, no, right, exactly, because this might break up here, but it doesn't break the entire circuit because it has this shunt wire there. All right, so there's a way to help people not ruin their time when they have only a serious pathway. Okay, so there are two pathways, right? Two pathways, and the circuit does not break. Does not break. It's essentially made like a little mini parallel circuit, which you did within the light bulb itself. Okay, guys, so go ahead and give you plenty of time for that. 25 seconds for this. Go ahead and raise your hands, guys. We're getting close to our last questions of the trimester. Just a few more. That's almost done. Okay, 11 seconds, guys. 11 seconds, 11 seconds, 11 seconds. All right, Haley, nice. Nice, Frank. Nice, Tim. Nice, Gabriel. Nice, Miriam. Okay, Angelina has it. Nina has it. Zach has it. Opie has it. Tay has it. All right, there's our time. Okay, let's see. Andre, did you get it? Did you get it, Ash? Shirley has it. Esteban. Okay, let's see. You missing anybody? All right, let's go ahead and go on to our next slide here.
All right, so now what we're going to talk about is resistance in a series. Now we know, imagine the current, which is the flow of electricity, is like students at the end of the school day. Each school building door is like a resistor. The more doors close, the more resistance, right? The more people are trying to pack through that door. And maybe if you experienced that, if your old school actually let you out and there was only like one door. Well, it's preventing students from leaving as easily as if there was multiple doors that would allow students to move in and out of school freely at the end of the day. I always think of those that any movie that's talking about the end of school, like the last day of school for before the summer, and they're piling out of the school. People are tumbling and everybody's trampling all over each other. That's kind of like what it is. Door is like a resistor. All right. Now, in order to find the total resistance in a series circuit, it's actually the sum of the individual resistors. We just have to add up the resistors in our series, which is pretty easy. Now, we're not going to do the parallel circuit because it's actually more complicated, and so the equation is just way out there, and I just decided, nope, we're not going to do that. This is the last class of the trimester for before we leave, so again, we are going to go ahead and just do this series circuit, which is just adding. Now, resistance is measured in a new unit, which is called ohms. It is kind of like that horseshoe, a Greek omega is what it's called, but that Greek omega is actually signifying ohms, okay? OHMS. So we make sure you watch for that when we do that. My school was like a mini college outdoor. All right, cool. That's cool, Miriam. All right, let's go ahead and do some practice here before we leave. Okay, but before we do that, I want everybody to go ahead and lock in number 8, the word sum. Raise your hand. I just cleared the raise the hand, so if you did raise your hand before, go ahead and raise it again. I'm going to only give you 20 seconds. This is a 3-letter word, S-U-M. Sum is our word. Go ahead and lock it in. Thank you, thank you, thank you. Got it, Tim. Awesome. Thanks, Frank, and thanks, Kinshana and Jolie, Wyatt, Brandon, Gabriel. Awesome. Nice job. Sum 41. All right. All right. Excellent. We're going to go ahead and move on just because of time reasons and constraints. All right, let's go ahead and practice this. So just like I said before, we're really just counting the resistors and adding them up. Remember, the resistors are going to be those squiggly lines here, okay? Right here, and right here. I have 3 resistors. I have 1, I have 2, and I have 3. So I literally am just going to put them on the line here, and I'm going to add them up. 5 plus 7 plus 3. And what is going to be my answer? What is going to be my answer when I add up 5 plus 7 plus 3? Good, Gabriel. Absolutely, Opie. Excellent. Nice job, Miriam and Brandon. Nice, Shivani. I see you in the chat box. Good job, Jolie. Beautiful. Yeah, I definitely agree with each and every one of you. It is going to be 15 ohms. This obviously is going to be the answer to number 9. This is going to be really how you find out the resistance in a series. Go ahead and lock in your answer. The answer box is going to be 15. Your units are going to be ohms. OHMS. So go ahead and put ohms for your units, OHMS for your units. I'm going to give you 25 seconds to go ahead and lock that in. Raise your hand when you are finished. Go, go, go. 10 more seconds, and I'm just going to go ahead and move on because of time. I want to make sure you get through everything here in class. Awesome job. Awesome, awesome. Let's go ahead and practice another one before you do one on your own.
All right, guys, let's do this one here. So again, for resistance circuits, it's pretty easy, just adding them up, right? Just adding them up. Resistor 1, 2, 3, 4. Okay, so basically what we're going to do is we're just going to imagine the current flowing around this circuit here, right? You actually can go either way at this point. It doesn't really matter, right? So current's flowing around here. I just covered that up. And we just want to basically just, do what we got to do here, do our quick math here. So you guys tell me, tell me what to do here. Let's see, let me get another color just to keep mixed up a little bit here. Okay, so over here, guys, says what do you plug in for resistor right here? Resistor 1, 2, 3, 4, etc. So let's see, go ahead and let's do one at a time here. So what is resistor number 1? What's that going to be? Resistor number 1 is going to be what? I just want to cover that up here. What are we going to do here? Tell me the number. So 3.1, okay, we can call that resistor number 1. So we will put that in there. So 3.1, I kind of drew below here. Okay, how about the second one? What should we put in the second line there? Okay, we'll do 4.2. Okay, that's fine. Yeah, we can go either clockwise or counterclockwise. It doesn't really matter, so I have to get them all. Okay, got 4.2 there. Big numbers there, giant numbers. And then, Gabriel's ahead of us here. He's at 6.5 for the next one. Okay, good. So we'll do 6.5. Got that right there. Kind of sideways, but that's cool. And then our last one is going to be what? We already got 3.1. We already got 4.2. Checking it off. We already got 6.5. It's going to be 7.4. Right, good. 7.4. 7 point. Little tailors on there. 7.4. Okay, good. Okay, go ahead and add those up. It looks like Giselle has it. I think I saw somebody else as well. Miriam got it. Gabriel got it. Right. Who else has it here? Okay, Shivani. Good job, Shivani. Okay, good. So we are going to put that in here down below. So 21.2, and don't forget your units, 21.2 ohms. Okay, and of course it's going to be the answer to question number 10. All right, hands up, guys. Guys are quick here. Angela, Tay, Shivani, Wyatt. I hope you guys all got it. I'm going to put the timer on here and let you guys put it in. I'm going to go forward here with this, and we're going to go on to our next one.
All right, this is our last question for the trimester working in our content. So this is a complete on your own. Again, what I told you before is to find the resistance of total resistance. You just add all the resistors. Well, if you look here, I have 4 resistors. So if you go ahead, if you want to, you could check your answers with us in the question and answers box. When you are finished, Yep, you add them all up together, Max. When you are finished, you are excused. Have a great day. Make sure you submit your notes. We will see you back here tomorrow. Tomorrow, remember, is our final exam, so make sure you come ready to work. And then, obviously, if you have any questions, stick around. We will be happy to help you out. If you need to go back, just let us know in the main chat. But if you want to check your answer, please let us know in the question and answers box. Again, have a great day. We will see you back here tomorrow. Bye now, everybody. Bye, Tim, and bye, Christina. All right, no worries, Brandon. No worries. I see that, Roman. Adios. Bye, Frank. Thank you, Gabriel, for letting me know about Jolie. Bye, Roberto. Back over to you.
All right, guys. Anybody else want to check their answer in the question and answer box? Go. Quite a few students asking here. If I missed you, if you asked a question like, is this